Hello, ladies and gentlemen. Today we're going to be talking about how to multiply and divide rational expressions. So what you're going to need is your notes, a pen or pencil, and a calculator maybe, if you want one. Our learning target today, or objective, is to learn how to multiply and divide rational expressions accurately, and by accurately I mean in the most simplified form. So before we start actually looking at some practice problems, we got to talk about some rules with multiplying and dividing. So when we multiply fractions, we multiply straight across. So for in this example with actual numbers, all we're saying is the top times the top, which is 1 times 1, is equal to 1, all over the bottom times the bottom, which is 4 times 5, which is 20. That's all we want to do for multiplying fractions. We just want to multiply straight across. When we divide fractions, we want to flip the second fraction, which is called the reciprocal. When you switch the numerator and denominator, that's called reciprocal. And then we want to change it to multiplication. Remember when we talked about multiplying by the reciprocal way back when? So if we're taking 1/4 divided by 1/5, what we want to do is 1/4 multiplied by the reciprocal, so times by 5/1. And now we're back to rule number 1, multiply fractions. 1 times 5 is 5, and 4 times 1 is 4. So that would be my final answer is 5/4. And last but not least, always, always, always simplify your answers. That's what makes it accurate in our objective, okay? Okay, problem number 1. We need to multiply these two rational expressions, or these two fractions. But we need to think about how the factors are going to play into this, because after we're done multiplying, we're going to have to simplify our big rational expression. And when we simplify, like in the previous video that we watched, we have to break it down into factors and then cross off what's in common. So why not start there and then multiply? So let's simplify each of them first and then multiply. So let's look at our first rational expression, or our first fraction. If we simplify 2x squared minus 10x, or if we factor that, to simplify it, we're taking out a 2x, and we're left with x minus 5. And then if we have in the denominator x squared minus 25, that's going to be a difference of squares, so x plus 5, x minus 5. Now we're multiplying that fraction by x plus 3 and 2x squared. I'm going to write this as 2x times x, and you'll see why. So now we multiply. So we simplified and broke it into factors for each fraction. So now we're going to multiply. And when we multiply, it's just everything in the top multiplied by each other, and then everything in the bottom multiplied by each other. So the top is 2x times x minus 5 times x plus 3. And don't FOIL that all out, or don't distribute that all out, because we want to cancel the things that are in common. So just leave it like that. And then we're going to multiply what we have in the bottom. We have 2 times x times x plus 5 times x minus 5. It's common practice to just write like coefficients and single variables in the front of the numerators and denominators, and then anything in parentheses go kind of to the right or to the back. So that's why I wrote 2x times x in the front. So now it's the stuff that we want to cancel so we can simplify. We have a common factor of 2, gone. We have a common factor of x. That's why I broke it up, because we have a shared x from the top and bottom, but we're going to keep an x in the denominator. So the 1x is gone. We have an x minus 5 here and an x minus 5 there. So those are gone, or we cancel them out, divide them out from the top and bottom. Now we're left with in our numerator x plus 3, and then in our denominator we're left with x times x plus 5. And now it's not so bad. We don't have that long of a rational expression. So that is number 1, and that's how we're going to think through the rest of these problems, and we have 3 more. All right, let's break it into factors, simplify, and multiply, all that good stuff. So first fraction, 4x squared minus 4x in the numerator. Let's take out a 4x. We're left with x minus 1. Now look at the denominator. Ooh, we have x squared plus 2x minus 3. That is going to be a trinomial pattern. So x times x goes in the front. Factors of 3, well, it's only 1 and 3, but we need that middle term to add to a positive 2. So 3 should be positive, 1 should be negative. Go to the second fraction or second rational expression. We have x squared plus x minus 6. That's going to be another trinomial pattern, so x times x. Factors of 6 that add to 1, that's going to be 3 and 2. We want the 3 to be positive and the 2 to be negative, so those middle numbers can add to a positive 1, all over 4x. So now we're going to multiply top times top, bottom times bottom. Here we go. 4x times x minus 1 times x plus 3 times x minus 2. I'm going to bring the 4x in the denominator out front times x minus 1 times x plus 3. Wow, this is going to cancel a lot of nice things. 4's are gone, x's are gone, x minus 1's gone, x minus 3 is gone. So we're left with x minus 2 for my final answer. That was so nice and clean. Number 3, if they don't give you a fraction and they just gave me a polynomial, x squared plus 6x plus 9, that's assumed to be all over 1. So it's not that it's not a rational expression, it's just a rational expression with a denominator of 1. So let's look at the first rational expression, x plus 2 divided by x squared minus 4, and we need to simplify him or break him into factors. So the numerator can't do much else, it's just x plus 2. X squared minus 4 is a difference of squares, so that's x plus 2, x minus 2. We're multiplying by this polynomial. Our denominator is 1. Excuse me. X squared plus 6x plus 9 is going to be a trinomial pattern. So x times x gets me to x squared. Two numbers that multiply to 9 and add to 6. Well, that would be 3 and 3. It's a plus 3 to add to a positive 9, add to a positive 6. All right, now we're multiplying top times top over bottom times bottom. So we have x plus 2 times x plus 3 times x plus 3 all over x plus 2 times x minus 2 times 1, but we don't need to put the times 1. Now let's see what can cancel, and it looks like all that I have in common is that x plus 2 factor. So I'm left with x plus 3 times x plus 3 in the top all over x minus 2. Another technical detail in math, because we have x plus 3 times x plus 3, we can write that as x plus 3 squared because it's getting multiplied twice. So we're just going to use an exponent to keep it nice and clean for our most simplified answer. So x plus 3 squared all over x minus 2, and that is my final answer. So when you have things that are multiplying and they're the same, use those exponent properties so that we have a nice and neat, clean answer so it's not so long. Our last problem is actually going to be dividing. So think back to the beginning of the video with when we divide fractions, we multiply by the reciprocal. Flip the denominator and numerator on that second fraction, which would be this guy, and then multiply. So let's just rewrite it right away before we forget. So 2x all over 3x minus 12 times, flip that fraction. So now my numerator is going to become x squared minus 6x plus 8 all over x squared minus 2x. Now go through the problem like we've been doing on the last three. So there's nothing to simplify in the numerator for 2x, but 3x minus 12, we can take out a 3, x minus 4, times x squared minus 6x plus 8. That looks like it's going to be trinomial patterns. So x times x, factors of 8, that add to 6 would be 4 and 2, and we both want them negative to multiply to a positive 8 and to add to a negative 6. And then my denominator, x squared minus 2x, they have an x in common, so that would be left with x minus 2. All right, now we need to just combine that into one fraction. So put all the numerators together and all the denominators together. So we have 2x times x minus 4 times x minus 2. 3, I'm bringing that x forward, times x minus 4 times x minus 2. Now comes the fun part where we get to cancel. The x's are gone, x minus 4's are gone, x minus 2's are gone, and looky there, our final answer is just a 2/3. That's so nice. That's a good one to end on. I'm happy about that problem. Okay, thank you, ladies and gentlemen. Thank you for taking such good notes, and I shall see you soon.